Students, very good morning students. Let's again start our online practical with the help of OLAFs that we have used also in the last experiment, that is for the determination of focal length of concave lens by using convex lens, and the methods that we have used there, that was lens in contact method. So is here first again what you have to do, if you are new, then for that one first you have to browse OLAPs, and after browsing it you will see this page that will open to you, and after that one you have to click on physics. Now when you will click on physics, then that time different class groups will be opened here, like class 12th, class 11th, and other all class groups will be open there. See on the screen like class 12th, again up on this one class 11th, and at all these all are just showing here. So students, what you have to do, you have to go for the experiment that we will today. The experiment that we will conduct here, that is the experiment for the diode characteristics. So you have to just click on this one, that is on the diode characteristic here. And when you will click again, just like in the previous video you have seen, number of options are given, that is like theory, procedure, animation, simulator, and at all. So here also you will see for this diode characteristic. Now this is the page that will be opened here, and this is our objective of experiment diode characteristic, that is to draw the IV characteristic curve of a PN junction diode in forward bias and in reverse bias. So first of all, if you will go for the theory section, then as you know, semiconductors are the materials which electrical conductivity mediate between that of conductor and insulator. And also the common semiconductor material, if you will see that, like silicon, germanium, gallium arsenide, and at all. Now semiconductors are of two types, intrinsic and extrinsic. Again extrinsic semiconductors are of two type, N type and P type. So this is all the theory of this experiment, and along with the experiment, what is the semiconductor device, what is semiconductor material, that is also given here. Now semiconductor diodes is given whenever we are just taking the combination of P and N type material, then diode is forming here. You can see here the symbol of diode that will help you to recognize diode from the circuit. And this is now the diode that is looked in real way, like this side is P side and this is now N side, where a silver mark you can see. So this kind of the patch is given to just to find out the, in which side N type material is present and in which P type material is present. Now after that, if we will do the biasing in diode, as due to depletion layer no current is flowing, so we are just doing biasing. And for the biasing, two methods are possible. Here this is our PN junction diode. We can connect it to just to replace or to reduce the depletion region that is formed. We can connect P side to positive and N side to negative, that is called forward biasing. And again for the case of reverse biasing, we can connect this PN junction diode in the manner the P side is connected to negative terminal of battery and N side is connected to positive terminal, so that is called reverse biasing. So this is the two things that or two biasing process that we will utilize here. And if we will draw the characteristic, then it means if you will plot the graph between I and V for forward and reverse biasing, this kind of graph you will achieve now. So this is our whole of the objective of this experiment. Now after this one, again let's go for our experimental procedure. So in experimental procedure, first you will write down objective of experiment, then you will go to the top on procedure from here. And in procedure you can see first option is given, that is materials required. So in materials required, what kind of materials we are needed for this practical, that is a PN junction diode, 3 volt battery, 50 volt battery, high resistance rheostat, 0 to 3 volt voltmeter, 0 to 50 volt voltmeter, 0 to 100 milliampere ammeter, 0 to 100 micrometer. So here why different voltmeter and ammeters are given. The reason here two types of biasings we will do. One is forward and second is reverse. So in one of the battery will be used in forward and one battery is used in reverse. Now voltmeter is also for the same and ammeter is for the same. So this micrometer that we will use in the case of reverse, and milliammeter we will use in the case of forward biasing. One way key we will use, and connecting wires. So this is all the materials that we are needed here for reverse and forward biasing. Now this is our circuit diagram that we will follow, not only for the just our real lab, as well as we will follow it in our online lab. So you can just make this circuit now and just keep with you to connect the circuit in our real lab. Now this is real lab procedure. And now for the reverse biasing also, again circuit is given. Only in reverse biasing what we are doing, we are just changing the position of P and N. Now this is here simulator procedure is given. So you can see in simulator procedure whatever we are performing in online lab. So in online lab we can see the procedure of simulator. That is the first thing, we have to select what kind of characteristics we want to draw for the diode. So like forward characteristic and reverse, that we can select. Then we can also select diode from the drop down list. So number of diodes are given there. Every diode has different properties. You can select that one. After that we can see circuit diagram, and I just suggest you to make circuit diagram and keep it with you, so that we need not to see circuit diagram. Next one, but here connections that we have to make here by seeing the circuit diagram, by clicking and dragging the mouse from one connecting terminal to other connecting terminal of the device to be connected. Now next one, after connecting all the wires, we have to drag the key to insert it. Then we can change rheostat resistance using the slider, and then also we have to select room temperature for this experiment. Now we can note corresponding whole procedure to do this experiment in online lab. Now the next thing after this one, you can here if writing section you are doing, so in writing section only you are just writing objective, then material required, then again you are going to theory, and then observation table. Here observation table for this experiment that is given, like for the forward characteristics we have to note down forward bias voltage, and then for that forward bias voltage that we will apply by using rheostat, we can note forward current. Similarly we can do the same procedure for the reverse characteristics, that is reverse bias voltage. We can vary that one by using rheostat again, and we can note reverse current. So let's again come to the experiment now after this one. So in just before experiment, again we can go to the third option, that is the animation option. So this animation option will help us to understand how to connect our circuit now. So let's watch here. Video will be here for this animation. So this video you can watch and you can learn by yourself also. Later we will also connect with so now here for starting this one, as this is whole complete things about this one. There are some actually network issue along with this one.
Diode characteristics. Circuit diagram of the experiment is shown here. Apparatus required for the experiment are shown here. Procedure. Using a connecting wire, connect the positive terminal of the battery to the lower end of the rheostat. Connect the negative terminal of the battery to one end of the one-way key using a connecting wire. The other end of the key is connected to the lower end of the rheostat. The rheostat is used as a potential divider arrangement. Connect the upper terminal of the rheostat to the positive terminal of the voltmeter using a connecting wire. The diode is connected between the positive terminals of voltmeter and ammeter. Connect the negative of the voltmeter to the negative of the ammeter using another connecting wire. Connect the negative of the voltmeter to the lower terminal of the rheostat.
Now you can see, student, this is our whole circuit, and then we have to insert key, and we can see now this voltmeter is moving. We have to note down now the figure. So I will just stop this animation video here, because up to this point we are needed only. After this one, let's go for our lab now. So for our lab, the fourth options that you have to click, that is on simulator option. So when you will click on simulator option, then the lab will be opened here, and in that lab first you have to do all connections, and even before connections you have to select proper diode and other all things. This is you can see the materials that we are needed here for this experiment, that is also given here. So these are 6 things that we are needed. This is the first thing, that is our high resistance rheostat. This is a cell we have used, or battery you can say. This is now ammeter. This is our voltmeter, PN junction diode, and a key we have used. Now we can connect any terminal by dragging it, any of the things, like just like you can just see this kind of wire you can see by dragging here. And now for this one, first you have to make selections from here for diode as well as for the characteristics. So for diode here are 2 types of characteristics you can see, that is forward and reverse. So first we are going for forward. Then diode we can select here, number of diodes are given, any one of the diode you can select now. Rheostat resistance and room temperature, we will just be able to select later when we will complete all the circuit diagrams. Now to complete the circuit diagram, again from here you can just click on show circuit diagram. You can see circuit diagram for the forward biasing, and even before this one I have told you that in the procedure option also. So let's start to connect our circuit diagram here. Connected here we have selected all the options, that is forward biasing and diode. So let's start our circuit connections now. The first as in your circuit you can see the cell is connected to the rheostat. So we can connect the cell to the rheostat by just dragging a wire from this one to point to this point. So here first connection we have made from cell to rheostat. Next one, one of the terminal of the cell, that is negative terminal, that is connected to the key here. So one wire we can drag it from this one, and then we can connect it from the key. Next one, the another point of the key is connected to the next end of the rheostat. So here this is our second end of the rheostat. From here a wire we can take and we can connect it by the key here. Then again we can take a wire from the upper point of the rheostat, and that can be connected to the diode here. Third connections that we made, the another side of the diode that will be connected to positive terminal of the emitter by circuit diagram. You can see this one. So this is the connections that we have done up to now. Next one, the negative terminal of the battery emitter, that is connected to one end of the rheostat here. So we can just drag a wire, you can connect it negative terminal. And here again students, I will recommend you to use laptop in place of mobile, because mobile is creating some problems. Now next one, connections again you have to do. So you have to connect one more wire from the this negative just side of the or one side of the voltmeter to the rheostat. One more connections we have to make from here to rheostat also. So that connection is not going to establish here. Let me just do it again. Now this you can see here all our circuit is connected, and when you will connect the circuit correctly, then that time you can see in your voltmeter and ammeter readings will start. So students, up to the connections we have seen here, and again you can see here the circuit diagram that is connected already. So here this side of rheostat we have connected to the positive terminal of cell, negative terminal of the cell is connected to one of the key, and then other side of the key is connected to this rheostat. So overall number of connections we have made using rheostat, because this is high resistance rheostat, so we can just make a number of connections with it. Now here you can see two of the connections. One is connected here with diode, and other one is connected here with voltmeter. Next one, after the other side of the diode is connected to emitter, and one of the negative side of the emitter is connected to again rheostat. So this is all our circuit here, and also we have seen the circuit diagrams of this one. After this, as the key we had to insert here, and after connecting this, whenever you will insert the key, then you can see readings will start to show in the voltmeter and ammeter here. Now what we have to do from here, this rheostat resistance, you can vary voltmeter according to your own, and you can note here current. So room temperature here you can fix by yourself. At different temperatures, obviously the voltage and current will be different. So you can select the temperature by yourself. Suppose here the temperature I have selected, that is 25 degrees Celsius. So at this temperature we are going to perform our experiment of PN junction diode, or we are going to just plot the diode characteristics for here in between forward current and forward potential. So first our biasing is forward biasing. Diode that we have selected here, that is IN4007 diode. And next one, sorry students for this. So the next one thing here, first if we are keeping rheostat resistance 1 ohm, then the voltmeter is showing reading 0.03 volt, and then ammeter is showing reading 0. So as you have already chart of this whole of the experiment, then keep that chart with you, and then put the values of voltage according to your own. You can note down the current here. So let's vary here the voltage by just dragging it. So you can drag it and you can keep the voltage by yourself. Suppose here the first one here, sorry students. So suppose 0.15 volt we are keeping. So at 1.15 volt we can see here the current is still 0. Again we can just increase it to 0.30. Again the current is 0. So you have to note here the voltage in this manner, and also the current for that voltage. Next you can also here vary this to 0.45, and you can see for 0.45 here we have started to get current now. So as you know, in forward bias already we are connected P side of the diode to positive terminal of the battery, and N side of diode to negative terminal. So it means electrons will get repelled by terminal towards the junction, and that's why they are getting high kinetic energy even to cross the junction. But until they are getting the kinetic energy up to certain voltage, they are not giving any kind of electronic current. So here we can see at 0.45 volt our ammeter is showing reading, that is 0.1 here. Next one, after this again you can increase the current, and then you can note down at 0.60, then that is 2 amp current here, and again you can increase and you can note down current by this one. So obviously we can just vary here potential up to 0.9, and we can note down current here for that one. So appreciable change in current we can see, that is 678, even up to that one, even for the short variation of potential in forward bias we are getting. So you can plot now the characteristic for forward bias circuit. Now for reverse bias condition, again we have to keep room temperature as 25 degrees Celsius. This room temperature we don't have to change, and also diode we are choosing, that is also same, but the characteristic of diode that we have chosen here, that you have to only keep the reverse bias. So when you will choose reverse bias, here one best thing is in this experiment, simulator experiment, you don't have to connect again the circuit, because circuit is already connected, only position of diode will be changed here. So in first case, if diodes P was means P side of the diode was connected with positive terminal, while selecting reverse biasing, the P side of the diode will be connected to here negative terminal, and N side is connected to positive. You can see now the diode, again I will just show you. Now you can see that variation in here, and also you can see variation in ammeter while changing this one. You can see this thing. So this is our first thing. Again you have to just drag your rheostat up to this limit by here, that is rheostat resistance. So and the room temperature is obviously 25 degrees Celsius. So again students, you have to perform this experiment in the same manner as you have performed for forward bias circuit. Like here you have to vary this potential. So again you can choose the same way, like 0.15 you can note down the current here. Again for 0.30 you can note down the current, and so on. So continuously you can see up to a certain voltage even we are not getting any current, but when you will just vary it, then overall as here basically current we are not getting. So the reason here why we are not getting current, that is this diode. So this diode has very high resistance, that's why we are not getting. Even you will select this diode, you are not getting even current for the maximum value of potential that you can provide here. Even you can see this one, also this one. But when you will select this one diode, that is IN270, for this diode you can see here you are getting current in this circuit. So again you can perform the experiment for this particular diode. So students, you have to note down also diode that is giving you different characteristics. Even you can see for this diode, for lowest one we are getting current here. You can again change it, you can see this one. So this is our way to see this appreciable change in different diodes also. Again let's keep the temperature, and while just varying temperature you can see there is also the variation in this one. So just follow the same procedure here for the reverse biasing. Means here we have to again select the diode. Even here while selecting diode, any one diode here up to IN270, or you can select IN34A. In these two diodes you can get readings of the experiment. Now continuously you can see here the experiment's reading is changing, and it is just going to be constant for a certain potential. It means that even the avalanche breakdown condition we are achieving for this particular voltage is when 30.7 unit value we are getting in ammeter. So this is the breakdown potential that you can obtain now. Here don't be confused if we are not getting at 0, we are not getting here 0 value of current. So you can note down here 0.03 volt, and for that one current you can note that is 14.1. Similarly if you will vary it, so in with variation just go for point here 10 or 0.09 you can also select, and for that one 25.9 you are getting. So you have to just find out that voltage for which you are getting maximum value of current for this diode. Again you can note down on this one, then you can note down on 0.15 also, and while varying still after this one 0.18 you are getting 30.0, and again you can vary. Yeah, you can see 0.21, that is 30.4 now. Like here you can see 30.7, and this is now 30.8 also we are getting. So this is our maximum value. So this is 30.8, the potential at which we are getting this one. That potential is here reverse breakdown potential, or that is also known as over here just avalanche breakdown potential. So I think now you can perform experiment by yourself by selecting different characteristics, by selecting different diodes, while keeping different room temperature. I just recommend you here for just finding out reverse bias characteristics, you have to put lower temperature, otherwise you will get very high value. So you can do by yourself, no issues. Any of the temperature you can keep here, and then you have to vary rheostat resistance. Along with that voltmeters value will vary, and you can see current from here. Now after doing experiment, after making charts, again here we have to go in procedure, and in procedure, as we have seen, this is our forward characteristics observation table, and this is now the reverse characteristics observation table. After that the calculation method, that is how to plot the graph, that is just given here. So you can plot the graph here, and in powered by characteristics, the emitter that was providing value in milliampere, and in reverse bias it was providing also value in milliampere here in this case, but normally it is providing the value in microampere. Now after this you can just put down the result of this experiment, that is forward and reverse characteristics here. So why as the number of diodes we have chosen and that was not giving us reading, that time reason was that they were providing current up to the order of microampere, but we have chosen our emitter that was milliampere, so that's why we had to change diode there. This is the reason behind that one. Now I think this complete procedure and of the experiment diode characteristics is clear to you.